Hey guys, today we're going to talk about limiting reactants. So we've already done stoichiometry problems, and in those problems we've used one item that we have a limited amount of. From here on out, I will give you multiple items that we have limited amounts of, and we'll go through the same process of calculating stoichiometric problems as we have previously. So what is a limiting reactant? When you solve through a stoichiometric equation, a limiting reactant is a substance that is required for a reaction that is completely used up. So previously when we talked about the ham sandwiches, the ham was completely used, but we had extra lettuce and extra bread. So for these examples, we are going to have substances that I give you a specific amount of, and you'll have to calculate which one is completely used up and which one has extra, and how are we going to go through the rest of the process. So the limiting reactant is the one that disappears completely because all of it is used. The excess reactant is the one that you have leftovers of. So in this example, again, we're going to food. Which reactant is considered the limiting reactant? We have 2 hamburger patties. We have 1, 2, 3, 4, 5, 6, 7 buns, and we're creating 2 hamburgers. So 2 patties and 7 buns. We use both patties, but we have 5 buns left over. So in this example, the hamburger is the limiting. That means that the buns are the excess reactant. So the limiting is completely used, the excess has extra. So here's an example using chemical compounds. We have 3 N2 molecules on the left, and we have 3 H2 molecules directly next to it. They react to form NH3. So which of these two is limiting? So for NH3, we need 1 N molecule and 3 H's to create NH3. So I've used 1, 1, 2, 3. Now we're going to make a second NH3 molecule and use this one, and 1, 2, 3. 1, 2, 3. So all of my H's are used up. I have extra N's left over. So my limiting is H2. My excess is N2, because N2 we have leftovers. So in order to work through limiting reactant problems, our first step is to calculate the number of moles present of 2 reactants. So we might have 3 reactants in the problem, but I'm going to at least give you numbers for 2 of them. So calculate the number of moles of each substance that is present. Then we have to compare those 2 substances by writing ourselves some new mole equations. And from those mole equations, we're going to determine which one gets used up first. Then we're going to complete the rest of the stoichiometric calculation just like normal. So you've done plain stoichiometric calculations before. Now we're just adding an extra step in there. So for example, we have 200 grams of sulfur and 100 grams of chlorine. Calculate the mass of disulfur dichloride that is created. So here I have the balanced chemical formula. I have S8, 4 Cl's, and 4 S2 Cl2s. And my first step is determine the number of moles of each reactant present. So first we're going to calculate S8, and we're going to use sample mass over molar mass. And I have 200 grams of sulfur, so I'm going to have 200 on the top. And since this is S8, I want to take the mass of sulfur, which is 32.06, and multiply it by 8, and that gives me 256.48. When I divide these out, I have 0.779 moles of sulfur. Now I'm going to do the same thing for chlorine. Now I do not need to worry about that coefficient out front. That's for later steps. For this step, all I need to do is sample mass over molar mass which is 100 divided by 70.9, and this gives me 1.41 moles of chlorine. So 0.779 moles, 1.41 moles. Now we have to write our coefficient ratio. So I'm going to go back to the previous slide just to take a look at what the chemical formula is, because that's going to be helpful for us. So the coefficient in front of S8 is 1, in front of Cl2 is 4, and in front of S2Cl2 is 4. So my coefficient ratio is 1, 4, 4. Now I have to write my 2 mole ratios. I'm taking my answers from the previous slide and plugging them in where they are supposed to go in our new ratio. So my number of moles for sulfur were 0.779. And since sulfur is in the first spot of this chemical reaction, that's where I'm going to put it in this new ratio. Now, to make this number change into the second number, I have to take that value and multiply it by 4. So 0.779 times 4 is 3.116. And now my next number is also 3.116. So this is written in terms of S8. Now I'm going to write the same thing in terms of Cl2. Cl2 is the second spot in our reaction, so I'm going to put that 1.41 from the previous slide in the middle. Since the second and third numbers are the same, 1.41 goes in the second spot. And to go from the middle back to the first spot, from 4 to 1, I divide by 4. So 1.41 divided by 4 is 0.35. So these are our 2 mole ratios. We have to choose the mole ratio with the smallest numbers. So we're going to compare one location, the first number of both or the second number of both. The first number here is 0.779. The first number here is 0.35. So chlorine is smaller. That means this is our limiting reactant. Now that I know what my limiting reactant is, and I have our mole ratio for that limiting reactant, I can go about the rest of the problem. So sulfur was here, chlorine was here, disulfur dichloride is in this last spot. So the number of moles created is 1.41 moles. So for our fourth step, calculate the mass of the unknown compound using that ratio. So the number of moles created is 1.41. And S2Cl2 has a molar mass, 2 S's is 64.12, 2 chlorines is 70.9, that is a total of 135.02 grams. And again, this can always be found by adding together their chemical compounds. And remember, this can always be found by adding the masses of the chemicals in the compound together. So we do not know the sample mass. So using the moles equals sample mass over molar mass, I have 1.41 equals my unknown over 135.02. Now I'm going to take those two numbers and multiply them together, and my sample mass is 190.37 grams. So we were able to create 190.37 grams of disulfur dichloride. Now this last step is just to help us prove that conservation of mass is a thing. Determine how much of the non-limiting reactant is left over. So we knew that we had 0.779 moles of sulfur. According to our new mole ratio, we used 0.35 moles of sulfur. So if we subtract those two numbers, we started with 0.779, we used 0.35, we had 0.429 moles left over. and 0.429 moles, sample mass over 256.48, and the sample mass of sulfur that is left is 110 grams. So we started with 200 grams of sulfur. This tells us we used 90 to create this chemical compound, to create this chemical reaction, and we would have 110 grams of sulfur left over that are completely unused. So in the next video, I have a few more examples of limiting reactant problems, but keep in mind we're going to be looking at these for quite some time. This is going to be something you're going to get a lot of practice with. So again, we have a few steps added in. Calculate the number of moles of the two substances provided. Write your coefficient ratio. Write your mole ratios. There should be at least 2. Choose the one with the smallest numbers, and then continue with your stoichiometric calculations. So I'll see you tomorrow so we can go over any questions, do another few examples, and work through this together.